In Chapter 3, we learned about the concept of median as a way to talk about the center of our data. And when we say the center of our data, in terms of median, what we're really saying is that half of the observations are smaller than that value and half are larger. So another way to talk about that being the center of it is that 50% are below that value of the median and 50% are greater than the value of the median. And so we can use that principle of what percent are smaller than a value or larger than a value in a more general sense. We don't have to just talk about the 50th percent. Okay, so again, the median is the 50%. Another term for that is the 50th percentile. But we can adjust what percentile we want to talk about, and that's what we're going to talk about here in Chapter 4. So instead of saying 50th percentile, we can say something like, what about the 20th percentile or the 37th percentile? And we can find the specific observation or that value of that observation that for which 37% are smaller than that value. And so to look at how we're going to do that, I'm going to pull up some Excel data here. And I just have, in the first column, I have just an observation number so we can kind of keep track or quickly find what we're looking for. And then in the second one, I have some just kind of randomly produced numbers. So if we wanted to find the median, let's start again with the median, but this time, so the median for the 50th percentile. Okay, these mean the same thing. So how do we do that? Well, remember we need to order our data. We need to sort the data. And in fact, just want to make sure I don't, let's see, I do not want to expand it because I do want to keep just the number. Let's do smallest to largest. Okay, so now I have my values ordered from smallest to largest. And the median, right, we have 39 values. I've done this just for simplicity. It won't always be quite so straightforward, but remember now we have an odd number, and so it's going to fall right on a value, and that value is going to be the 20th. Right, so at the value of 20, there'll be 19 less than it, and there'll be 19 more than that value. And so our median is 30. Okay, and again, remember if it's not right on a value, or on one of the, if we have an even number, we'll need to kind of split the difference. Right, so if I had a 40th value down here, the median would be in between 30 and 31, and we'd call it 30.5, taking the halfway point of those. Okay, but I said we can be more general than this. We can talk about things like, what is the 25th percentile? Okay, and another term for the 25th percentile is going to be the first quartile. Okay, quartile meaning we're splitting it up into quarters, right? So there's 4 quartiles. So we have the first, the second quartile, which is the median, and then the third quartile, right? So I could have maybe organized this different, but the third quartile, and we'll calculate these here in a second. The third quartile is the 75th percentile. So you can refer to it in either way, in the third quartile or the 75th percentile. Strictly speaking, the first quartile would include, or you could think of it including all the values less than that. So if you wanted to talk about values that fall within the first quartile, it would range from all the values of 2 up to whatever we determine it is. So what is the first quartile? Well, it's where only 1/4 of the values are, or the 25% are smaller than that value. So again, with 39 values, we can maybe think through this just logically and figure out if it's exactly at 10 or where it is. But there's an equation to help us, and that equation is, we use the equation LP just to say location of percentile. Location of percentile is equal to n plus 1, and then p divided by 100, where p is the percentile that we're interested in. Okay, so for the 25th percentile, we would plug in, let's see, let's just do that over here. So L25, okay, just to remind ourselves, the 25th percentile is equal to n plus 1, where n is our number of observations, so we have 39 plus 1, and then times, we want 25 over 100. Okay, and so this is going to be 40 times 1/4, and so we are going to, in fact, find 10. Okay, so again, we could have maybe guessed that's where it was going to be, but in a more general sense, this works for any number of observations and any percentile. So we found that the 25th percentile is the 10th observation. It doesn't mean that it is 10. The answer is not 10. We need to then take this this 10th observation and look it up in our column here. So the 10th observation is 11. So our answer is actually 11. Okay, so the 25th percentile, or the first quartile, the kind of the border of the first quartile, is 11. Similarly, with the 75th percentile, L75, again, this is 39 plus 1. So that's not going to change at all, but what percentage we're looking for does change. So now we want 75 out of 100. And again, the math here is pretty simple. This is 40 times 75 over 100, which is going to come out to be 30. Again, the answer is not 30, but we need to look for the 30th observation, which is 45. So this is observation number 30, observation 10, but the actual percentile is the value we look up in the ordered data. So why do we use terms like quartiles instead of just always the 25th percentile or 75th percentile? Well, number one, it's easier to kind of know that we're breaking it into quartiles. So when we talk about quartiles, we know that we're already splitting the data into 4 groups. So really the first quartile are the values from observation 1 to 10 here. And so you could think of the quartiles being broke up in kind of this sense. Let's just kind of pick some colors here. And again, remembering that the second quartile is equivalent to that median. And then we have a third quartile and a fourth quartile. And the fourth quartile, it ends at the last observation, so you hardly need to calculate it. But we've broken our data up into 4 quartiles. We can do this in other breaks. So you often hear deciles, right? So what would be the first decile here? Well, what is a decile? It's 10, right? Deca. And so in that sense, see if this computer will register. The first quartile is not registering. There we go. Okay. The first decile, right? Dec is in 1/10. We would refer to it as, so LP, remember, is n plus 1 and p over 100. And so here we would want, this again is going to be 39 plus 1 and then 10 over 100. Right? And so that's going to be 4 in our case. So the fourth observation here is 3. And so the first decile is 3. And you may recognize this type of language in terms of, or oftentimes say income or wealth is broken up in that regards. And so we may talk about the bottom 10% of income earners, or the top 10%, or the top 1%, right? So the top 1%, that's not a decile, that's just a percentile. So we can be more general. We don't have to stick to these breakdowns as quartiles, deciles, quantiles, things like that. We can talk specifically about an exact percentile, and you may have seen this again in things like income, or in terms of oftentimes like so if you have a child or you have younger siblings or something, you may have seen these kind of growth charts in terms of baby Sue is in the 93rd percentile in height or something. And so those are times when we refer to those quite often. And there, that's more general. So let's just pick. Okay, we're curious about the 37th percentile in our data set here. Well, how do we calculate that? Well, that's still going to be L37. So this was L10. L37 is 39 plus 1 times 37 over 100. And so that's 40 times 37 divided by 100 is going to be 14.8. Okay, so the 14.8 observation, right? Remember, we need to take it one step further. Oftentimes, or one place that can trip people up is we calculate this value and then we say, oh, okay, well, that's the 37th percentile. This is just giving us what observation to look for. So in our case, it would be 14.8. So the 14.8th observation. So we have a 14 and we have a 15 here. Now, this, similarly to median, sometimes we fall in between values, or there's not a specific, right? So in a median with even numbers, we're looking for instance, the 20th and a half observation. Here we want the 14.8. So it's 16 or 18, so it's somewhere in between those. And in general, so sometimes you'll see it as some statistics books will just talk about kind of like in the median, you just take the average. So the simplest is to just take the average. Now, our book here lays it out in a more specific way and a more mathematically correct way. But there's quite a bit of nuance here, and I don't want you to get too bogged down in that nuance. And I probably won't test you on the specifics, or I won't test you on the specifics of this final part of the calculation. But I do want you to be aware that there are ways to handle this in-between value. And the way we would handle that is to say we actually want to be 80% of the way to the 15th observation. Right? We're at the 14th. We want to be close to the 15th because we're at 14.8. So really we want to slide 80% of the way to the 15th. And so one way to think about that is we have our 14th observation is 16, and our 15th is 18. And we want to be closer. We want to be 80% of the way down here. So we can calculate that by doing 16 times 0.2 plus 18 times 0.8. And that would give us an 80% of the way there. So again, don't stress too much about that specific calculation. If you, in general, if you're ever actually dealing with percentiles and whatnot, you'll often be on a computer and it can do this precise calculation for you. But more generally, I want you to make sure that you're kind of conceptualize what we mean by percentiles and quantiles and quartiles, and know that you can look up the specifics as to how to crunch the exact value. In this case, it ends up as 17.6. Right, and that's 80% of the way from 16 to 18. Or another way to think about it is, what is 80% of the distance of 2 here? Right, there's a distance of 2, so going 1.6 is 4/5 or 80% of the way. and that's how we get to 17.6. So two kind of ways to think about it is, what's 0.8 times 2, which is the distance, which is 1.6, and then add that to the 14 or to the 16. Sorry. So that's just the final step. There is if you're in between values, there are ways to calculate the exact position. But yeah, in general, this is a flexible way. Knowing this, once we know this formula, we can find any percentile we want. And you will, as you go deeper into understanding statistics and seeing them pop up, even in popular news articles, we talk about percentiles a lot. So hopefully this helps that concept sink in.